Now suppose I have to find out the non-negative integral solution of maybe this equation, that is x plus y plus z plus p is 10. I'm finding out non-negative integral solution, that means 0 is allowed, right? So what I have to do, it's n is 10 over here, r is 4, because these 4 persons are there, or these 4 variables are there. So it's n plus r minus 1 c r minus 1. So it's 10 plus 4, 14 minus 1, that is 13c3. This is the answer, right? So 13c3 is the total number of solution, or we can say non-negative integral solutions, right? So this is non-negative integral solutions, right? And if I have to find out the positive integral solution, what I will do, n minus 1 c r minus 1. So n minus 1 is 10 minus 1, that is 9c3, right? So this is positive integral solution and this is non-negative integral solution, right? Now let's take some more variation in this. Now suppose I have an equation that is x plus y plus z plus p is maybe say 12, right? Or we can say ki I have to distribute 12 apples among x, y, z and p, so that x should get at least 1, y should get at least 2, z should get at least 3 and p should get at least 4, right? You can assume that this to be a condition, right? So x should get 1, y 2, z 3 and p 4, that is minimum number of apples that they should get, right? Now what I do, I just give them the minimum apples first of all, then distribute the remaining ones, right? Because all the apples are identical. So what I can do, I'll give 1 apple to x, 2 apples to y, 3 apples to z and 4 apples to p, right? So in all 4 plus 3 7 and 2 9 and 1 10. 10 apples are already distributed, right? Now we have to distribute how many apples now? That is 2. That means x plus y plus z plus p is 2, right? That means I have now I have to distribute 2 apples among 4 people. That means now I have to find out the solution to this equation. Now in this case, which type of solution I have to find? That is non-negative integral solution. Non-negative. Why non-negative? Because now 0 is allowed. See, minimum their minimum requirement has already been filled up, right? Because I have already distributed 1, 2, 3 and 4 to these persons, right? Now if they get any of them, if they get 0 also, no problem, because minimum requirement has been fulfilled, right? Or obviously at least 2% will get 0, because now we have just 2 apples, so only maximum 2 people can get the apples, right? So we have to find out the non-negative integral solution. And what's the formula for that? It's n plus r minus 1 c r minus 1, right? If you wish to use formula, you can, else you can go conceptually, right? So what's n over here? It's 2. What's r over here? It's 4 minus 1 c 4 minus 1. So it's 4 plus 2 6 minus 1, that's 5 c3. So that's 5c2, that's 10 ways, right? So 2 apples can be distributed among these 4 people in 10 ways, and that's the answer to the problem, right? Friends, alternatively what we can do, instead of non-negative integral solution, we can find out positive integral solution as well, right? What I do is, I when x is like if I have to distribute 1 2 3 4 to x y z and p respectively, what I do is I give them z x y z and p 0 1 2 and 3, right? I distribute them 0 1 2 and 3. Now I find out the positive integral solution. Positive integral solution means they will get at least 1. Now since x is having 0, if he gets at least 1, so in all he'll be getting 1, right? 1 or more than that, right? Similarly, y is as of now having 1. So by distribution, if he gets at least 1, so in all he'll be getting 1 or more than 1. That means at least 1 he'll be having, right? I'm sorry, at least 2 he will be having, because 1 is he is already having, and with positive integral solution he'll be having at least 1 more. Similarly for z and p, right? So in this case what we can do is, our equation is x plus y plus z plus p, that is 12, right? I distribute 3 plus 2 5 and 1 6 among these people. So the remaining distribution is x plus y plus z plus p is 6, right? Now I have 6 apples, right, to be distributed among 4 people. So I have to, and I get the gaps 1 2 3 4 5 gaps are there. From these 5 gaps, if I select 3 gaps, so I'll be getting 4 partitions, right? So from 5 gaps, let's select 3, so it's 5c3, and that's equal to 5c2, and that's equal to 10, right? So in this case the answer will remain same, because in this case we have found out non-negative integral solution, so 0 is already included. In this case we have found out positive integral solution, because initially x, y, z and p are having 0 1 2 3 apples, and we want them to have at least 1 2 3 4. So the positive integral solution, if we find out, they will be getting at least 1 2 3 4, because they will be having at least 1 in their kitty, right? So this is how we can approach this problem, right? I just take one problem that has come in a previous year CAT papers, so let's do it.